was this here, finding the least common multiple of these three numbers. We did it. Yep. Now we could go through and list out all the factors of 9, 18, 27, 36, 54, or 45, 54, 63, 72, 81, 90, 99, 108, and going out until we get at least enough of them that I think I have the possible least common multiple between these two or three here. Now that could be listed enough, or we could have to keep going further. There's no real tell which one it could be. I think the a little bit nicer way, especially with these three numbers, is to look at the prime factorization. So we start by seeing what multiplies together to give us 9. Well, that'd be 3 and 3, because 3 times 3 is 9. Now we look at 12. I try to start with the smallest numbers as I can, except for 1. 1 doesn't tell us much of anything. Well, the first number we know that goes into 12 is 2 and 6. 2 times 6 is 12. Now 2 is prime, because I can't divide anything into 2 besides 1 in itself. So we'll look at 6, 2, and 3. Now for 9, I didn't write it, but really its prime factorization is 3 times 3. 12, since we have it all the way written out, is 2 times 2 times 3. And lastly, we have 15. 15 does not divide by 2 nicely, so it's not going to be a factor. The next number after 2 would be 3, and that would be 3 times 5. Now 3 is prime. That is as small as it gets, and incidentally 5 is also prime. So the prime factorization of 15 is 3 times 5. Any questions on this here before we find the least common multiple? No. We just need to find all of them. Because once we find all of them, then we're going to start looking at the numbers. Now, which factor we start with really doesn't matter. We could start with 5. Because I know 15 has one factor of 5 in it. 12 has 0. And 9 has 0. Now, because the most times 5 showed up as a factor for 9, 12, or 15 was once, it does only need to be listed in the least common multiple once. Now we can move on to 3. 15 has one factor of 3. 12 has one factor of 3, and 9 has 2. So we look at this here to figure out how many 3's we need. We look for which one has the most factors of 3, which is 9. And since it has 2 of them, we need 2 of them in our least common multiple. Even though 12 and 15 had it once, because 9 had the most, that's how many factors of 3 we need. Now we need to look at the last factor that's listed, which is 2. 12 has 2 factors of 2 in it, yes? 9 has 0, and 15 has 0. So how many 2's do we need? 2 of them. So whatever the least common multiple is, we know we need 2 2's, 2 factors of 3, and 1 factor of 5. Now at this point here, we can do this by hand. We can do it in a calculator. 2 times 2 times 3 times 3 times 5 is 120. 80. That is the least common multiple of 9, 12, and 15. Questions on this here? Mm-hmm. 2 times 2 is? Yeah, you're good. Yeah, no, I wrote it out step by step to get there. Yeah. But if we just plug it all into a calculator, we get 180. Yes. And it does help us figure out also what we need to multiply each one of these by to get to 180. Because with our 9, it has the 2 3s, yes? What is it missing from that least common multiple? The 2 2s and the 5, yes? So if I take 9 and multiply it by 2, 2, and 5, those 3 factors it's missing, we get 180. The 12 has the 2 2s and 1 3. It's missing a 3 and a 5, yes? So if I say 12 times 3 times 5, we get 180. And the 15 has a factor of 3, has a factor of 5. It's missing the what? The 2 2s and an a 3. Times 2 times 2 times 3. That's 180. Questions on this here? Find the least common multiple of 4x squared minus 16 and 6x squared minus 24x plus 24. Now to do this, especially with expressions, we need to factor each one of these expressions completely. We need to factor it down as far as it'll possibly go, and that's going to help us be able to see what the common factor, or what our least common multiple is. The first expression, we can make both of these expressions be the same. Now with our 4x squared minus 16, the first thing I would look for is the greatest common factor. I mean, there has to be one, but if there is, we need to factor it out. What number can divide into both 4x squared and 16? Because if we divide 4x squared by 4, 4 divided by 4 is 1, leaving us with x squared. If we do the same thing with 16, 16 divided by 4 is 4. Now we need to factor x squared minus 4. We have 2 terms being subtracted, so there's a good chance this is a difference of perfect squares. X squared kind of gives me a big hint towards that, because x squared is x times x. Now what times itself is 4? 2 and 2. So this is a difference of perfect squares, which means the signs are going to be opposite. So it's going to factor to x plus 2 times x minus 2. Questions on this here? Be good with this here so far. Now the next part, we need to factor 6x squared minus 24x plus 24. Is there a number or term that will go into all 3? Well, we know it's not going to be a variable, because we do have x squared x, we have a number without x. So x is not involved in all 3. So we're really looking at a number that will divide into 6, 24, and 24. And it's 6. So that means we can factor this 6 out of all 3 terms. And we factor it out, we move it to the front and divide it out. Our 6x squared divided by 6, 6 divided by 6 is 1. So it'd be x squared. 24 divided by 6 would be 4, we still have our x, and lastly, the 24 would be 4 as well. So we have 6 times x squared minus 4x plus 4. Now at this point here, again, we can factor x squared minus 4x plus 4. Since the third term is positive, the signs are the same and match the sign of the middle term. If the third term was negative, the signs are opposite. Here, the third term is indeed positive, so our signs are the same and match the sign of the middle term, so it'd be negative and negative. Factors of our first term, factors of x squared are x and x. That's the only set. Now our factors of 4 are 1 and 4 or 2 and 2. Well, good chance we want 2 and 2. Now I'm going to go on and check and make sure, because if this does, we multiply it out, we're mainly checking the middle term. If it does indeed give us the correct middle term, these are the correct factors. Now x times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2x minus 2x, negative 2 minus 2 is indeed negative 4, which is the middle term we wanted, yes? So those are the correct factors. So now that we have it factored, we can find the least common multiple. So the first one we need to find the least common multiple of, I try to start with the factors that are outside the parentheses. So in this case, the two numbers we have outside the parentheses is 4 and 6. So we're trying to find the first number we can turn both 4 and 6 into. It is not 2, because 2 would be the greatest common factor, not the least common multiple. So to do that, well, we can come over to the side and have our factored forms of 4 and 6. Well, 4, as we said already, is 2 times 2. We kind of found that when finding the factors of 4. 6 is 2 times 3. So we look at this here. 4 has 2 factors of 2. That's actually all it has. 6 has how many factors of 2? 1. Which one has the most? 4. And it has 2 of them, so we need it listed twice. 6 has 1 factor of 3. 4 has, so we need it once. 2 times 2 is 4, and 4 times 3 is 4. So the first number that we can turn both 4 and 6 into, the least common multiple, is 12. Now, for the most part, doing the multiples 4, 8, 12, 16 wouldn't be too bad. 6, 12, we get there pretty quick. Unlike the last 3, where it took us to 180, we had to go 20 terms out for 9. That would take us a lot longer. Here, we can kind of get there. We ready for our expressions? So let's look at both of them. And we'll start with, say, x plus 2. How many times does the expression x plus 2 show up on the one on the left? How many times does it show up on the one on the right? So how many times does it need to be listed? Yep, x plus 2. Well, the other expression that the one on the right or left has is x minus 2, yes? How many times does it show up? Once. If we look at the one on the right, oh, it does show up, but it shows up. So how many times do we need it? Twice. Because again, the whole goal with least common multiple, we're going to call it eventually least common denominator, is to get these two expressions to be the same, yes? Well, the one on the right has 2x minus 2's. So if I want to get them to be the same, the one on the left needs to have how many? 2. We don't want it to have 3 because, well, they would become the same, but I'm adding an extra one on both sides. and especially when we start adding or subtracting, in solving, any extra factor that I add in is going to have to be simplified out. Which, again, I said this yesterday with numbers. We add an extra factor of 2 in, we divide 2 out. Numbers are nice. But especially when we start getting these extra expressions, that means we're going to have to factor it out of the top. Which means instead of it being a quadratic and x squared, it's now an x cubed. Or if we add 2 of them, instead of it being x squared, it's now x to the 4th. It makes the expression bigger, more that we have to do to factor. So if we don't need to add it in, we don't want to. Now, on that same thought, the one on the right is missing an x plus 2. So if we want to get them to be the same, I would multiply it by x plus 2. We're trying to get them to be the same. That's the whole goal. Questions on this here? Find the least common multiple of 6x squared, or 6x squared minus 54, and 9x squared minus 54x plus 81. Doesn't mean there has to be, but I would always start with the greatest common factor for either one. 6x squared minus 54. Is there a number or term in common with both? Is there a number that goes into both 6x squared and 54? Or does it divide by 6? And 6 definitely divides by itself. So we can divide it out of both terms. We put it in front. So 6 times x squared minus 9 is the same as 6x squared minus 54. So we factor that greatest common factor of 6 out. Now it looks like x squared minus 9 might factor, because we do have a difference of perfect squares. X squared kind of gives me a hint it's a difference of perfect squares, not cubes, because x squared tells me it's x times itself. It's a square. So that's kind of a hint. Now all we need to know is, can we rewrite 9 as 9 a number times itself? What times itself is 9? 3. And since it's a difference of perfect squares, the signs are opposite. As x times x is indeed x squared, yes? So x times x is x squared, yes? That's 3 times negative 3. 3 times negative 3 is negative 9, yes? Okay. Well, let's just check and make sure we got this right with the middle term. X times negative 3. Wouldn't it be negative 3x, yes? Positive 3 times x would be positive. Negative 3x plus 3x is 0. Did we have a middle term? No, so we should expect that middle term to be 0. So these are the correct factors. Now we don't normally check it because, I don't normally check it because it is a theorem. A squared minus b squared is equal to a plus b times a minus b. Now we look at the other one. 9x squared minus 54x plus 81. Is there a greatest common factor between these three terms? 9. 9 will go into all three. Because if we divide 9 out, really we're just dividing the numbers. 9 divided by 9 is 1, leaving us with x squared. 54 divided by 9 is 6. 81 divided by 9 is 9. Now at this point here, we do hope that x squared minus 6x plus 9 will factor. So we'll write our two sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here the third term is positive, so the signs are the same, and they're going to match the sign of the middle term, which is negative. So we have negative and negative. Factors of the first term. Well, factors of x squared, we only have one set. They're going to be x and x. Factors in 9 are 1 and 9 or 3 and 3. And we're most likely going to be using what? 3 and 3. And we can check and make sure. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3x minus 3x is indeed negative 6. Negative 3 minus 3 is negative 6. So that is the correct middle term. That's the one we want. Questions on how we got to this point here? Least common multiple. We can start with 6 and 9 first. We don't have to. We could start with our parentheses if we wanted to. So we need to figure out what is the first number going up that we can turn both 6 and 9 into. Anybody have a guess? 18. Because if we look at 6, 6 is 2 times 3. 9 is 3 times 3. So we know whatever the least common multiple is for 6 and 9. 2 shows up once, so we're going to need it once. Showed up near times for 9, so we only have it once. 3 shows up once for 6, but twice for 9, so we're going to need it twice. 2 times 3 is 6. 3 times 6 is 18. Or 3 times 3 is 9. 9 times 2 is still 18. So it tells us that the least common multiple of 6 and 9 is 18. So we know we'll need 18 for them to be the same. Now the one on the left has the expression x plus 3 once. The one on the right has it 0 times. So how many times do we need it? Once. The one on the left has x minus 3 once. So we know we will need it at least once. The one on the right has it twice. So how many times do we need it? Twice. So the least common multiple of these here is 18 times x plus 3 times x minus 3 times x minus 3. Leave it as this here. Do not multiply it back out. No reason to. Because again, we're using this to find out what the denominators need to be so we can actually add the two fractions together or get them to be the same. When it gets to solving, when we start solving, we're trying to find the expression we need to multiply the entire equation by to get the denominators to go away. Because it's a lot easier to solve or add if they're not fractions. We can't do this with expressions because there's nothing that they're equal to. We can't just simplify the fraction out. Questions on this here? Let's look at one more. 5x cubed and 10x squared minus 15x. Let's start with factoring 5x cubed, x squared. Now 5x cubed first. We ready to factor 5x cubed? Okay, we're finishing factoring 5x cubed. Because 5x cubed is one term, this is as simplified as it gets. We really can't do anything with it. It is 5x cubed. Now the 10x squared minus 15x. There's a good chance that we're not going to have our two sets of parentheses with 3 spaces. Because for us to have that, we either need an x squared term and a constant term, the number without a variable, or 3 terms. We don't have either, because we have a term with x squared and a term with x. So the first place I would look for is a greatest common factor. Is there something in common with 10x squared and 15x? 5. So we can factor out the 5. We can also factor out the x, because they both have x squared and x. And if we factor 5x, we divide 10x squared by 5x. 10 divided by 5 is 2. And when we remove one of the x's from x squared, we get x minus 15 divided by 5 is 3, and the x factors out completely. So we factor that out. We have what's left inside the parentheses is 2x minus 3. The degree is 1. There's nothing left in common with 2x and 3. That's as simplified as it gets. And that's actually completely factored. So if I want to find the least common multiple between these here, again, I said it doesn't matter where we start. Let's start with the parentheses this time. The one on the right has what? 2x minus 3. Now, since it showed up once there, we know we'll need it at least once. Even if the other had it 2 times, we know it has to show up at least once. While the other one has it 0, so 2x minus 3 is only showing up once. In the least common multiple, it's going to show up only once in either spot, so we just need it. Let's look at 5. So we need to find the first number to turn both 5 and 5 into, yes? Well, what is that number? Five. They're already the same, yes? So there's nothing that I need to do to them to make them be the same, since they're already the same. And yes, I can actually look at the 5 and x independently because they're being multiplied together. Now, the only other thing left is the x's, yes? Now, I know for sure we have to have at least one because it shows up at least once in either one of the two expressions, yes? The one on the right has how many x's outside the parentheses? 1, because it's just x, yes? The other one has how many? 3, because it's to the cubed. It's to the third power, yes? So how many x's do we actually need? So the least common multiple for this here is 5x cubed times 2x minus 3. Yep. Because the whole goal is to get them to be the same. We're looking for the first expression that makes them be the same. Now, for the most part, we're going to write this out and do this on the first few problems, especially with addition and subtraction. And once we get past that and start seeing what it is, we're going to look more at what the denominators are and see what the other one's missing to make them be the same, because that's the goal. That's why we're using least common denominator or finding it. And by the way, least common denominator and least common multiple are the exact same thing. The only difference, because denominator is where? The bottom of the fraction. So least common multiple, we're trying to find the expression that makes them be the same, the common multiples, or just an expression. Least common denominator, we're doing the exact same thing, but we're looking at the denominators of the expression. That's the only difference. Now, before we do that, well, first thing we're going to want to do is factor the denominators, because we're wanting to make them be the same. Because for us to be able to add or subtract two fractions, the denominators have to be the same. I will tell you this here, even if the numerators factor or are factorable at this point, I would not worry about factoring them, because we're going to have to multiply both expressions by something and then combine like terms on top, which means if we factor the numerators, we'd have to unfactor them, we'd have to distribute back out. It's a lot of unnecessary work. Now, the first one I'm going to start off with is 9x squared, because it factors to 9x squared. Nothing we can do with it, it is 9x squared. Now, if we look at the other one, 3x squared plus 3x, is there a greatest common factor? Yes, it is 3x. Now, if we factor 3x out of 3x squared, we're left with x plus. Because when we factor 3x out of 3x, it factors out completely. We divided 3x by 3x. Anything divided by itself is 1. So we have the denominator simplified, yes? Now, for us to be able to add or subtract, we need those denominators to be the same. And that's where the least common denominator comes in. Our least common multiple, that's just focused on the bottoms of the fractions. Now again, it doesn't matter where we start with finding this. We can start off with our constant terms or our expressions outside the parentheses or the parentheses. Well, if I start with the parentheses, the one on the right has x plus 1 listed once. The one on the left has it 0, so we know whatever is going to make them be the same, we need that x plus 1 at least once. It has to be listed once. That's kind of nice. We can go to the x's next because I feel like the x's are kind of nice. Because I can look at the one on the right. How many x's outside the parentheses do we have? 1. On the left we have 2, so we need at least 2 of them. And we will finish this to